One of Albert Einstein's most important insights is that empty space can be curved, and what we call gravity is really just a consequence of those curves. That's not an easy concept to grasp, so scientists use all kinds of analogies to help explain it. The most common is probably the grid dipping under a planet, star, or galaxy. We asked two physicists to walk us through the concept.
It's really about how light in space behaves. Up until Einstein came along, we had a way of thinking about what space was, about what mass was, that was very different. Usually we think of space as just being this empty thing, and we think of it as if you've got light traveling, it travels like a laser, it travels in a completely straight line.
It's only when using very precise equipment like the Hubble telescope that it becomes obvious that isn't true. We can see that if light had to pass close to something massive on its way to Earth, it arrives at a weird angle.
So light rays are not propagating already along straight lines. They are propagating along curved lines.
This is one of the major predictions of relativity, that matter curves spacetime and that we can see that curvature simply by observing how light gets to Earth.
It follows what space does. So if space curves, then light is going to curve.
When you take a particle which has mass and put it to space-time, then the particle actually distorts the geometry of space-time, which becomes not flat but curved. And this is the curvature of space-time.
And that's what the bent grid, or so-called trampoline, is meant to illustrate, helping us get our heads around how space curves in the presence of matter.
And the trampoline seems to be very successful in helping people to kind of get this idea.
If you take a big sheet of rubber and put on that rubber some heavy body, it will make that rubber kind of curved.
And now you start rolling marbles across it. You can get them to go all the way across, but they'll bend as they get close to that dip in the trampoline.
This is what happens in the real world. And so this is how we can trace the presence of curvature in the experiments with the light rays.
Unfortunately, the trampoline analogy only goes so far because the universe isn't two-dimensional, but it's a good starting point.
But then you have to translate it into 3D space. When you try to conceive of that in 3 dimensions, it just messes with your head.